Hi, hello friends, welcome to my YouTube channel. Now, in this session, we will discuss the 3S Genco 8015 Electrical Solutions Part 11 here. The question on the screen is, an experiment with a thermocouple with one junction is at 0 degrees Celsius. The following data were obtained at 0 degrees Celsius. So theta is given in degrees in Celsius and E is in millivolts. So 20, 100, 300 and 0.10194 and 0.850 and 1.650, assuming the parabolic relationship between the temperature and the EMF. The calculated neutral natural sorry it's a natural, not neutral, it's a natural temperature for this thermocouple will be about. So let's see that the characteristics of the given quantities is E, and in x-axis I will take theta here. The relationship between E and theta is like a parabolic shape here. So here we will have natural temperature. What is the meaning of natural temperature here? It is nothing but when if you are increasing the temperature in x-axis at a one particular point, the EMF will be maximum. After that, it will trying to reduce this EMF value here. So the empirical formula that we can give here is E is equal to alpha into theta plus half into beta into theta square. So this is the empirical formula. But in the given problem, the question examiner doesn't discuss about this alpha and beta constants. So which type of thermocouple they didn't mention here. That is the reason why. So we will take this as a constant here, and we will try to put the values in the graph here. So for example, say for 20 degrees, how much we are having here? 0.194. And similarly, we have another value. So for 100 degrees Celsius like that. So 100 degrees Celsius, what you're getting here? It is 0.850. So in the same manner, if you go on increasing at one particular point, so the slope, that is dE by d theta, is going to be 0. That is change in EMF is 0, and the changes and theta will change here. So at this particular point, if you uh, get the calculations, this value is around 350. That is a this value is got by trial or error method. Okay, so here we got is the answer is 333 degrees per Celsius, which is less than this value. So the whatever the value that we got here is a trial and error method. That's it. So by substituting different values here. Okay, so this is the answer. Next question. Next question on the screen is, a moving coil ammeter has a fixed shunt of 0.02 ohm resistance. If the coil resistance of the meter is 1000 ohms, the potential difference of 500 millivolts is required across it for full scale deflection. Under this condition, the current in the shunt would be. So this question is from measurement subject. So let's see, take an ammeter here. So ammeter is having how much shunt? It is 0.02 ohm shunt here. So shunt means parallel. So here we have resistance of the meter is 1000 ohms, and here we have ammeter here. So they are connected like this. So when this ammeter reading, how much voltage is required? It requires 500 millivolts. Oh, now what is the question? So now we want to find here is what is the current flowing to the shunt. So simply by applying Ohm's law. So what we get the Ohm's law? So VSH is equal to RSH into ISH. So we need to find ISH value. So ISH is equal to, what is the VSH? So 5 millivolts divided by, what is the resistance? 0.02 ohms is nothing but 25 amperes of current. The answer for this one is 25 amperes. Right. Next question. The next question is, measurement of a non-electrical quantity involves the following four subsystems. Okay, so first we'll see what is a non-electrical quantity. It may be a mechanical energy, or it may be a pressure, it may be a displacement. So here the transducer will convert non-electrical quantity into a electrical quantity. So now this whatever the electrical quantity that we got is small in magnitude. That means it is small signal. So if you want to small signal means if you want to amplify it, we need a amplifier block to make it as a strength signal. So amplifier block we will use here so that the weak signal is getting into a good strength signal. So now here we have a strength signal. So signal here. So it's a good strength signal. So what is the signal here? It's an electrical quantity, isn't it? So the electrical quantity is given to instrumentation block. So this instrumentation block will convert this electrical quantity into a human understandable quantity. So with the help of display systems. So these two are nothing but these two works are done by meters. Okay, and here we will have output. So if you see here, the answer will be D, A, C, and B. The answer is 1. Okay, next question. The next question here is the equivalent series resistance of a capacitor C in terms of its power factor and operation frequency is given by. So let's consider a resistor is in parallel with a capacitor like this. It's a combination of resistance and capacitance. Now what we want here is we need to find what is the resistance value in terms of its power factor. So normally, so power factor is nothing but it's a cos of angle theta, which is equal to resistance by impedance here. So in this circuit, R is nothing but square root of R square plus XC whole square. So here we are assuming that the resistance is much less than XC, so that we can neglect this value and we'll take Z as XC. So this is the approximation that we are making here, and we know that XC is nothing but 1 by 2 pi FC in terms of its frequency and capacitance, right? Now we substitute here. So power factor is equal to R divided by Z, which is nothing but R by XC. Now what is the R value? So R is nothing but power factor into XC. XC is nothing but power factor divided by 2 pi FC. So in the given options, A is a approximate answer for resistance value. And the next question, the piezoelectric transducer is used to measure. So piezoelectric transducer which will convert the non-electrical quantity into a electrical quantity here. So the non-electrical quantity here is in the given option is displacement only. So actually it is force. But here resistance, current, temperature, these two are electrical quantities and this one is a non-electrical quantity. This is measured by thermocouples. Okay. So thank you friends. Thanks for watching my video. Have a nice day.